everyone. I'm Laura, and here we are for lesson 56, Angles in Circles and Proofs. There aren't a whole lot of example problems for these, but all the information you're going to need to do the homework is coming up. So let's get started. Okay, first of all, some of this stuff you may have learned a little bit before, and this will be a nice reminder for you. First of all, we have in every circle, when you have arcs, you have a major arc, which is the bigger arc, and the minor arc, which is the smaller arc. And this all the way around is going to be the major arc. And this little arc right here that you see from this side is called the minor arc because it is smaller. Do you remember what kind of an angle this is called? It's called a central angle, and that means that the measure of the angle is the same as the measure of the arc. Now, when we look at the other side, the measure of the angle is also the measure of the arc. This arc is 290 degrees because this tiny little piece is 70 that we saw over here. Now, remember that when we do measure an arc, if we've got a major arc, we have arc BC, and we put the little arc over it. And over here, though, for a did I call this a major arc? If I did, I misspoke. This is a minor arc. For the major arc over here, we use 3 points, and so this would be CXB, because we need people to know that we're not indeed using this part, but we are indeed using this part. Okay, let's move on. All kinds of fun information today. All right. Secant, chord, and tangent, which includes point of tangency. What is a secant? A secant is a segment that goes through the circle, dun, da, da, right there, but it doesn't end on the circle. It goes through the circle and it touches the circle at 2 points. Now the chord is the one that stops at the edge of the circle. Its endpoints are on the circle. That is a chord. It's a piece. And a chord that goes through the center, what do we call that one again? A diameter. That's right. I'm sure you all knew that. Also, we have a tangent, the line that touches the circle. I know it's really hard to tell, but mathematically, some things are hard to see. Actually, this tangent touches the circle at 1 and only 1 point, and that is the point of tangency. And the tangent is always perpendicular to the radius of the circle at the point of tangency. So, when we look at this, we know that our point of tangency is right here, and our radius has to be perpendicular to the point of tangency, or the tangent is perpendicular to the radius. So there is that, and let's move on. Inscribed angles. Okay, we've got a couple of things here, and one is that we need to remember, of course, the blue angle here is not an inscribed angle, because an inscribed angle has all points and the vertex, both points and the vertex on the circle. This is a central angle. This is an inscribed angle. And the central angle is 60 degrees, like we knew before, because it's the same as the arc. An inscribed angle, however, is half of that. And so the measure of angle A here is going to be half of 60. You could almost see it, which is 30 degrees. What's next? Oh, let's look at these. We have different ways of having things inscribed. Here, this arc of 60 degrees, both of these angles, they have their endpoints here on the circle, but it can go any which way. So, for example, it doesn't have to be, there isn't just one angle. A is 30 degrees, B is 30 degrees, and let me try this. if I click on here and want to edit the points, oh, it's not going to let me edit the points. Let me edit the points, doggone it. Let's see if this will work. Here we go. I can take this and go anywhere on this circle, and angle A then is still going to be 30 degrees. It doesn't matter where it is on the circle. If it shares this arc, then it's going to be 30 degrees. Okay, let's move on. What's next? We've got lines that are intersecting the circle. Let's talk about that for a moment, shall we? Okay, these lines right here intersect inside the circle. So can we find X and Y? Of course we can. The rule is that if we, let's see, how does the book put it? They're very succinct in how they put it. The angles formed equal 1/2 the sum of the measures of the intercepted arcs. Okay, that's math speak. What this means is that X is going to be 1/2, so we can divide by 2, the sum of 40 plus 80, which means it's going to be 60. You can also, if you want to, write it like this, 1/2 40 plus 80, it's going to get you the same thing. So you know that X is half of the sum of these two arcs, the intercepted arcs. All right, over to the other side. So here, X is going to be 60 and Y is going to be 60. This could also be X. Perhaps that was a typo. Okay, and this is X right here. So the question is, what happens if they intersect outside the circle? Well, if they intersect outside the circle, the measure of the angle formed is 1/2 the difference of the measures of the intercepted arc. So for this one, you see, it's half of the sum if they're inside, but if they're outside, then X equals 1/2, I'm going to divide by 2, of 80 minus 40, and that means that we're going to get 20 degrees. So X is 20 degrees. So what is the difference, or how can we remember this? Well, inside we add, outside we subtract. You can also, the same way for this one, X equals 1/2 of 80 minus 40, still going to be 20. Okay, let's move on. Ooh, look at these. They look interesting. Wonder what these are all about. Let's find out. In the diagram that we just looked at, those rules, those are exactly the same as these. You just have to ask yourself right here, are these intersecting inside the circle or outside the circle? If it's outside the circle, then it's going to be the same. And these are intersecting outside the circle. What is the difference? The difference is that they're just touching here, and these are just touching and touching. They're not actually crossing into the circle, but the formula is going to be the same. The question is this going to be adding or subtracting? Well, it's going to be subtracting because they're intersecting outside the circle. So this one is going to be X equals 120 minus 60 divided by 2, which is going to give us 30. X equals 30 degrees. The little degree sign is already there. And look at the next one. It's the exact same thing. We're going to have X equals 360 minus 100 divided by 2. So 260 divided by 2 is going to give you 80 degrees. And let's see, if this is going to be 80, because these are the same, They are vertical angles, so that means they're both going to be 80. And this one right here, those are also vertical angles, so those are going to be the same at 30. And let's see, I think that's all for this one. Let's move on. All right, now this is the proof part. And this is going to be a little bit tricky, and I want you to write it down like this, where we have the proof part up here. This is what we're going to prove, that the vertical angles formed when chords intersect equal half the sum of their intercepted arcs. Now that's the math speak for what we just talked about with circles. So I want you to go ahead and write down on one side when we do proofs. I don't know if you've done them before like this, but I want you to write the statements and the reasons. And the statements are, this is what I'm saying, this is one step, and the reasons go on the other side. This is why I'm saying this. So we're going to step through this and just see how it goes. First, we need to remember a few things. Whoops, it's right here. We need to remember this rule right here, which is the sum here. The sum of these two angles are equal to the sum of this angle, which is the measure of the exterior angle equals the sum of the remote interior angles. Because we can look at this and we can say, what have we got here? Oh, look, we've got a bunch of remote interior angles. And we have an exterior angle right here. We need to make sure that we see that when we look at these pictures. When we do proofs and that kind of thing for geometry, the most important thing that we can do is be able to recognize what's in our picture and what is given. So what we have here is we've got, like I just said, we've got two remote interior angles. And we have an exterior angle, which is 1, and it goes either way. Now, let's do the proof. It's going to be a little bit hard because I'm going to have to try and write small. We'll see if I can't get it all in here. What are we given? Well, what do we know? That the sum of the measures, and this is my little shorthand, you'll get used to it. The measure of the exterior angle equals the sum of the measures of the remote interior angles. That is given. So what is the second thing we have to recognize? Well, that means that angle 1, or I should say the measure of angle 1, but we can write it like this. Angle 1 equals angle 2 plus angle 3. Look at our drawing. I wish I had room for the whole drawing and everything else. Sorry that I don't. So we know that 1, there we are, 1 equals 2 and 3. Why do we know that? We always have to have reasons in geometry. Why do we know that? We know that because it's an exterior angle. And that is the definition. You could even call this, some teachers will say, oh, it's not because it's an exterior angle. It's the definition of exterior angles. But I'm going to leave it at it's an exterior angle right now. So what does that mean when we look at this picture? We've got arcs here. We've got AD, we have DB or BD, and we have AC, and we have BC. What do we know about angles? Well, we know that we have, I'm going to use the blue, I think. We've got angle DB, and we have angle AC. And when we look at this, if we look at angle 2, we can see that this is an inscribed angle. So that means that it is 1/2 of AC. And we look at DB here, and we see that that is an inscribed angle through angle 3, and that is 1/2 of DB. And this is, let's see, that's going to be 3, and this one is going to be 2. So if I write that down, I could say, if we know that angle 2 is the same as, I'm going to write down every step for you. It's not going to be the same as in the book though, so be prepared. So angle 2 is 1/2, what did I say that was? Angle 2, AC. And angle 3 is 1/2 dB, because they are inscribed angles. And then for number 4, through substitution, we could say that angle 1 is 1/2 of AC plus 1/2 of dB. And that's just from substitution. All right, now we can always substitute things, when we find out that they are equal. So if I can write it like that, that means I can factor out the 1/2 and say that angle 1 is 1/2 of AC plus dB, and that is from factoring. And that means we've just proved it. That's what we were trying to prove, that the angle 1 is 1/2 of the sum of the intercepted arcs, which is AC and dB. Ta-da! We've done it. Now, if you can't quite follow those steps, that's okay. I want you to pause then and go back and try and step through it again with me, so that you could see how things go. When we do proofs, we got to make sure that we do our reasons. It does get kind of sloppy when I'm doing them online, and I apologize for that, but this is it. And it's a pretty short proof. It's only 5 steps. We go from what we are given and head to what we are trying to prove. Let's do another one, and this is the last proof we have for today. And then there are no examples at all. But you do need to have all of these things in your notes in order to do the homework. So don't think this is just going to get you off easy, because it never does. All right, what are we proving? Prove that the angle formed by 2 secants that intersect outside a circle equals 1/2 the distance of the intercepted arc. What? Well, that's what we talked about. 1/2 the distance. Remember when it was x, in this case, it's going to be this right here, equals 1/2 AC minus BD. And we let them know their arcs. That's what we are trying to prove. So what are we given? We're going to use our exterior angles. The measure of exterior angles is the sum of the remote interior angles. Alrighty, where do we go next? Well, we have to look at our picture. And whoops, we're looking at our picture. What the heck? Let's go back to the picture. There we go. All right, so we're going to look at our picture, and we're going to do some things that are going to help us out here. First of all, we're going to draw, a chord. Hopefully yours is straighter than mine, from A to D. Then we're going to label 1, 2, and 3. Now the first thing we have to recognize is that 3, if we look at this triangle right here, and we see that this extends out here, we see that 3 is an exterior angle. So what do we know about exterior angles? We know that they're the sum of 1 plus 2. So the measure of angle 3 equals the sum of 1 plus 2. Let's write that down. Angle 3 equals angle 1 plus angle 2. Why is that? Because it's an exterior angles. All right. Then what do we do? Well, we have to keep going. Let's say instead of 1 plus 2 equals 3, remember we're trying to get here. That angle 1, instead of x, it says angle 1, we can call that angle 1, is going to be, we're going to have to use some subtraction. So all we have to do is do a little bit of algebra. We're going to subtract because we want to get angle 1 by itself. So we'll subtract angle 2 from over there. So we have angle 1 equals angle 3 minus angle 2. You see how that's going on. And then remember what we did before when we substituted? What is the measure of angle 3? It's an interior angle or an inscribed angle, so it's going to be half of AC. Angle 3 is half of AC. So we'll write that. Step 4, angle 3 equals 1/2 of AC. You see where we're going here? Minus angle 2, which is also an inscribed angle. It is half of BD. We'll write that down too. 1/2 of BD. Oh, what should we call number 3? We'll just call that algebra. And then for 4, we will call that substitution. And what did we do last time? We factored out the 1/2. So 5 is angle 3 equals, whoops, I made an error. Did you see my error? I called this angle 3. And that is not angle 3. It's still angle 1. It hasn't changed. Angle 3 is over here. So angle 1 is 1/2 of AC minus BD. And that was just factoring. And is that not what we were trying to figure out? 1/2 of AC minus BD, or DB, either way, as it says in the book. Now, there is something that they write at the end of every proof, and that is this, QED. And you know what? I don't remember what that stands for, but I will figure it out and remind myself and let you know what that stands for. Okay, guess what, friends? That's it. QED basically means proven. We've done it. And I should put it at the end of all of the proofs to be official, I'm certain. Okay, just in case the geometry police come after me. I would hate to be arrested. All right. There we go. And we don't have any example problems, but and I don't believe, let's see, I don't think you're going to have to prove anything. At least I hope not. Nope, no proving. You just have to use this information, and at some point you will have to prove things. So it's good to get into the understanding of this is how the process goes. This is what you use, you know, the kind of format that you can use. You take what you're given and you move step by step to prove what you want to. And so just use this information, especially all of these beginning notes up here. These little formulas and stuff, that's what you're going to need for your homework. And I'm promising you, my friends, that if you didn't draw the circles along with the formulas here, like these little formulas right here, if you didn't draw the circles, you probably should go back and do that, because that'll be very helpful in your notes in the future. You know, the way you continue to have this spiraling curriculum, these problems aren't going to go away, and you're going to want to be able to flip back real quick to all of your notes. All right, friends, that's it for this one. We will catch you later for lesson 57. Whoa.